Hey there, it's Alana, and I'm back to help with yet another question. All right, so this is technically 3.2, number 23 from the study plan. Again, if you open up the textbook, that's what you'll see, or if you click on the online book or open it up online, physical book, whatever, it'll be number 23 from this section. All right, now I'm not going to do the actual problem. Like usual, I'm going to do the example, and then you'll kind of see how it goes. Okay, so it says the following data represent the weights in grams of a random sample of 50 candies. So here they are. Determine the sample standard deviation weight. Okay, so I'm going to click over here on this little icon. It's kind of small to see, but it's over to the right of the table. And it's in there, by the way, here for the non-example. See it right there to the right. Okay, so that's how we get data sets. And I'm using this little guy to make the entire problem spread out over the page, and you can't really see it here. Let me make it smaller for a sec. So I have the option open in StatCrunch, copy to clipboard, or these other four, and these four are kind of more computer science-y kind of things, so you only use those if one of the first two doesn't work, right? But in general, I almost always, like 90% of the time, copy to the clipboard, even if I'm going to use StatCrunch, and I'll show you why. So let me make this bigger. So I copied in my clipboard, and I go to Excel, and I Control V, paste. There they are. And you know what? I'm going to insert a thing up here. So I, oh, you probably want to know what I did. So I clicked on the number 1, so it highlights the whole row. I right-click, insert, and then I'm going to type weights. You don't have to do this, but I just kind of like to do it. Okay? So there they all are. And then what you can do is you can highlight all of these. Oh, you're probably wondering how I did that so fast. So I clicked on this, I hold down Control and Shift. So I clicked on cell A1, I hold on Control Shift, and I press the down arrow. And it highlights all of them in the entire column. And then I press Control C, or you can go to Edit, Copy right up here, that copy button, that'll work. And then I go to StatCrunch and I paste it in. I click on Variable 1, VAR1, right. And actually, you can't do the right-click thing because it's a web thing. So you just Control V, and there they are. Now, as I said in other videos, I like StatCrunch as its own window. You open StatCrunch as its own tab. Do not open it in here. Even though I know it's in there, StatCrunch, I probably should make that disappear. Maybe I will. But it's just not a good way to get to StatCrunch because it houses it inside my math lab, and that makes the computer programs sort of fight with each other and not talk really well. You're better off just going to www.statcrunch.com and using your same login and password that you use to get in to my math lab, because my math lab pays for your access. So you have free access to StatCrunch as long as you're in the My Math Lab course. Okay, so you open it as its own tab. That's actually better even than opening it here. If you click on Open in StatCrunch, which is that top one right there, you'll see it opens it in StatCrunch, but it's in this weird funky window, and sometimes these windows don't work as well as having them be their own separate tabs on their own separate browser. Your computer sometimes doesn't like them, it'll block them, and it's just a pain. So again, I copy and paste to Excel. So I copy to the clipboard, paste in Excel, and then I copy and paste from there into StatCrunch if I so desire. And I highly recommend that for all of you as well. StatCrunch is awesome. It seriously is awesome. It's the only thing you'll use from chapters 9 on. But it can be kind of a pain with the copying and pasting. The safest thing for me, have it in its own tab, in its own little browser tab, and then I just paste whatever I need into it. Okay, so the first thing they want is the standard deviation, I think. So the sample standard deviation S. So you can find that a whole bunch of ways. I'll do it down here. Actually, you know what? I'm going to do something. Hold on. View. I'm just going to make it so you can see the top bar real quick. I'm going to freeze my top row. There we go. So that way when I scroll down, crafty, huh? You can see the weights and stuff. But you can see I'm now down at row 51. So all the other rows are there. They're just kind of getting moved up. Okay, so for us, the sample standard deviation, that's equal to STDEV. Okay, old school Excel, that's all you say, STDEV. And actually, it'll work in the new school Excel, but I like using the new functions, which is STDEV.S. S because this is a sample, right? And then you tell it what cells. So I can use my mouse and highlight, or I can just say A2 colon A51. Because I can see that's what it's going to be. A1 had my weights label in there, So 2 is where my data actually starts, and 51 is where it ends. And if you don't believe me, you can kind of scroll up and see it. There it is. That's the other way to do this, is to kind of highlight the data as you go. So you say stdev.s, and then I hold down my left mouse button and I drag it up. It's just kind of slower that way. And I get the same thing, A2 colon A51. And there you go. There's your S, 0.068. And they rounded to 2 decimal places. You can do that too. There's a couple ways to do that, but probably the fastest way is just to format your cells accordingly. So if you right click on the number cell and say I want number and I want 2 decimal places, there, it's rounded it 2 decimal places. Cool. All right, so we did that part. Lovely. What else do they want? So then they say, is that bell shaped? Yeah. Ish, and that's all we really require. It doesn't have to be perfect for our purposes, right? So, good enough. Honestly, we apply the empirical rule to things, anything that vaguely looks normal. Even if it's not picture perfect normal, it's close enough. Okay, so yep, sure, fine, whatever, empirical rule is good. Okay, so then it says use the empirical rule to determine the percentage of candies between 0.7 and 0.98. Okay, and they say the mean is 0.84, but I don't believe them. I'm going to find the mean. The mean is equal to the average of A2 colon A51, because 51 was where my data ended. And sure enough, they were right, it's 0.84. And I'm going to make it 2 decimal places again, just for the sake of it. Okay, so they're giving me, let me think, what was it, 0.7 to 0.98. Okay, so let's think about this for a second. If your mean is at 0.84, okay, then your mean plus 1 standard deviation, 1s, let me just put that way, 1s, will be equal to 0.84 plus 0.07, right? And then the mean plus 2 standard deviations, 2s, would be equal to that value plus 0.07. And then, honestly, I could have dragged this along. There you go. All 3 of them. This is the mean plus 3s. I'm just trying to give you the values, or trying to calculate the values for the, I'm going to make this bigger. There. I know 0.84 is in the middle. I'm trying to figure out what this bar right here is, where this bar right here is, and where this bar right here is. If I had a piece of paper, I would actually kind of draw this picture and then start labeling things in there. Okay? As a matter of fact, I could do that, but that would be kind of a pain. All right, so then mean minus 1s, mean minus 2s, 2 standard deviations, mean minus 3s. I'm trying to figure out the ones on the left side there. I'm trying to find out what those numbers are over here. Okay, so this would be equal to that guy, 0.84 minus 0.07, right? Because that's how much a standard deviation was worth. And if I really wanted to be funky, I mean, if I really wanted to be awesome, I could use this cell and give it dollar signs, because the 0.07 never changes, right? And then I could just drag it along. That's another way to do it. Crafty, huh? I could have done it over here. Instead of plus 0.07, I could say plus that cell, give it dollar signs. That way it never changes as I drag, and then just drag it along. And technically this guy is equal to that cell right there. Nifty, huh? All right, so then for the question that they were asking about, they're asking about 0.7 to 0.98. Cool. All right, hold on. Let me go draw a picture. Poof, there it is. And actually, I noticed that while I was gone making that picture, that it was becoming a little bit inaccurate. The reason being because if I use the cell reference, remember this was rounded, so it's not... it wasn't perfectly rounded. It actually knew all the decimal places behind the scenes. So when I used it, it was actually making a little bit of an issue up here with incorrect numbers. They weren't technically incorrect. They're actually more correct. But because we're assuming that we've rounded a bit, it wouldn't work out. So suffice to say that now I'm just using 0.07. I'm calling it a day, even though technically 0.068 or whatever it was would be more accurate. Okay, so I drew this picture, and now what they're asking me is what percentage is between 0.7 and 0.98, I think. Let's see. 0.7 and 0.98. Well, that's easy. 0.7 and 0.98 is simple, because each of these sections has a percentage that you know from back in section 3.2. Oh, let me go draw a picture of it. Hold on. There we go. All right. So remember, there's a, and you don't have to memorize this kind of thing. This can go right on your note sheet. That, the middle is 68%. That means 34% is on each side. And then this middle right here from 0.70 to 0.98, which is what they were actually asking about, is 95%. And that's what these four numbers add up to, right? So if you take 13, equals 13.5% plus 34% plus 34% plus 13.5%, you get 95% for those four middle ones. But of course, I could ask you all sorts of ones, like what is it to be higher than 0.84? That would be 0.5. And what a lot of students forget is that this 1.05 and beyond to like forever, like Buzz Lightyear, to infinity and beyond, that all makes 0.15%. It's very small, but it's not just between 1.05 and 1.12, the next standard deviation. It's actually all of them, all the way up. Okay? All right, so there's the answer to the question we were looking for, which was part C. Okay? It was 95% if you add up those four numbers in the middle. Okay? But of course, you could add up all sorts of different combos of numbers. All right, now let's go back. What else did they want to know? Let's see. Oops. They're just showing the pictures and everything that I already did. All that good stuff. Okay. Let's see here. Blah, blah, blah. All of that. All of that just to get the 95. And what they're showing you there is you draw the curve, you put down the numbers, right? Start with 0.84 in the middle and add on 0.07, subtract away 0.07. Then you put in all your percentages. And remember, none of the percentages have to be memorized. A picture like that should just go right on your note sheet for your tests. Okay, then the last bit is determine the actual percentage. So when you look at your data set, what actually was between 0.7 and 0.98? Okay, good question. So let me see if I can do this. What I want to do is I want to sort my data. So I'm going to highlight all my data. I'm going to go to, just to keep things from getting all messed up, here's what I'm going to do. I don't want it to sort my S and my mean, so I'm doing kind of something a little bit funky here. I highlighted the S and the mean part, all that stuff, and then I'm moving it so that the cursor is you kind of hover it on the border and it turns into a four-way arrow, and then I hold down my left mouse button and I drag it over. In fact, I'm just going to drag it over here. There. Then it's not part of that column, and then I'm not going to worry about it getting sorted with the column. Everything will be great. I think I could have done it without that, but I'd rather not have a snafu happen. So I've highlighted my column. I just clicked on the A, or up here in this A region, and it highlights the whole column. And then I go to Data, and I'm going to click this A to Z button. That'll sort it from lowest to highest. And you can see my particular data set didn't have anybody that's lower than 0.7, because we're interested from 0.7 from this. I better highlight this, from this one, green one, to this one right here. Okay, so those are the two numbers I'm concerned about. So if I look at these, I didn't have anything lower than 0.7. Like if I had a 0.68, I would count that. And then all the way up, everything, except for this one right here. So for me, for my data set, there was 49 out of 50 of them are between, here, let me do this way, between 0.70 and 0.98 is equal to 49, right? And then the percentage, if that's what they want, which I think it is equal to 49, that's that number, divided by 50. And that would be 98%. And then you could just right click and format the cell, make it a percentage if you so desire. There it is, percentage. Cool. And if you don't want decimal places, that's in there as well. You can say I want a percent with no decimal places or something like that. But there's the answer right there. All right. So that's what it is for me. There is a trickier way to get it to count that for you, but honestly, I think it's just kind of easy just to look at it. So you just look at the high end, anything past the 0.98 mark, and look at the low end, anything lower than 0.7, which we didn't have in this case. So for me, it's 98%. Let's double check my work. Hey, look, 49 out of 50. That made 98%.